In this video, we're going to be writing a quadratic function. In one, it says, in the previous module, we worked with the two equations w plus L is equal to 16 and LW is equal to 39. In this module, we will work with the equations w plus L is equal to 16 and L times W is equal to A. Note, A represents a function. The equation which relates the variables L and W to a constant is called the constraint equation. We'll proceed in the same manner as we did in the previous module. So the first thing they want us to do is solve the constraint equation for W. So we're going to subtract L from both sides, and we have W is equal to 16 minus L. And now we want to substitute the expression into the function and simplify. So we're going to say that A is equal to L times W, and W is represented by 16 minus L. And now I'm going to distribute the L through the parentheses, so I can say that A is equal to 16L minus L squared. And now we're going to write A as a function of L. So we're going to have A as a function of L is equal to 16L minus L squared. And now they ask us what kind of function is obtained. And we have a quadratic function. And now they want us to write the function in vertex form. So the first thing we're going to do is find h, and h is equal to negative b over 2a, which is equal to negative 16 divided by 2 times negative 1, which is equal to 8. And we also need to find k, and k is equal to a of 8, which is equal to 16 times 8 minus 8 squared, and this is equal to 64. So in vertex form, A of L is equal to negative L minus H, which was 8, squared, plus K, so plus 64. And now they want us to state the vertex, and our vertex was 8, 64. And now they want to know, what is the maximum value of A? And the maximum value of A is the y-coordinate of the vertex, so 64. And now they want to know what value of L maximizes A. And the x-coordinate of our vertex was 8, so when L is equal to 8, we're at the maximum value. And now it asks, what value of W maximizes A? In order to find this value of W, we're going to start with our W is equal to 16 minus L, and we're going to plug our L value that maximizes A, so we're going to have W is equal to 16 minus 8, so W is equal to 8. In the box, they give us steps to solving a max-min problem given a function and a constraint equation. 1. Solve the constraint equation for a variable. 2. Substitute into the function to obtain a quadratic function in one variable. 3. Write the equation in vertex form. 4. State the vertex. And 5. Answer the question. So in 2, it says given x plus y is equal to 15 and q is equal to x squared plus y squared, they want us to write a quadratic function for q in terms of x. Find the optimal value of the function and the values of x and y that optimize the function. So the first thing we want to do is solve the constraint equation for y, and our constraint equation is x plus y is equal to 15. So we're going to subtract x from both sides, and we get y is equal to 15 minus x. And now we want to substitute this expression into the function and simplify. So we have q is equal to x squared plus y squared, or 15 minus x squared. And now q is equal to x squared plus 225 minus 30x plus x squared. So q of x is equal to 2x squared minus 30x plus 225. And now we want to write the resulting quadratic function in vertex form. So we're going to have h is equal to negative b over 2a, which is equal to negative 30 divided by 2 times a, which is 2, and this is equal to 30 over 4, or 15 over 2. And now to find our k value, we're going to say k is equal to q of 15 over 2, which is equal to 2 times 15 halves squared minus 30 times 15 halves plus 225, and this is equal to 225 over 2. So now in vertex form, q of x is equal to a, which is 2, times x minus h, which was 15 halves, squared, plus k, plus 225 over 2. So our vertex is 15 halves and 225 halves. And now they ask us, does this function have a maximum value or a minimum value? And since our quadratic function opens up, we have a minimum value. And now they ask us why, and it's because our parabola opens up. And the parabola opens up because our x squared term is positive. And now it asks, what is the minimum value? And our minimum value is the y-coordinate of the vertex, or 225 over 2. And now they want to know what values of x and y optimize the function. So if x is equal to 15 over 2, and our constraint equation was y is equal to 15 minus x, so we have y is equal to 15 minus 15 halves, so y is equal to 15 halves. So we can say that the function has a minimum value of 225 over 2 when x is equal to 15 halves and y is equal to 15 halves. And now if we wanted to check, we can say that q is equal to x squared plus y squared. So q is equal to 15 halves squared plus 15 halves squared, which is equal to 225 over 2. And that's all for this video on writing a quadratic function.